OpenSCAD. This is one of the jankiest pieces of software that I've used, and it's what I chose to design the laser machine. The laser machine which for a little while bore the name of Fisher-Price CNC because it was made of components from a monoprice 3D printer which turned out to be a total pile of crap. It's so janky that the low frame rate of the preview window is that's not because I'm recording the screen, that's just how slow it is. I actually have a pretty good graphics card in my computer. So this is a sort of mechanical design of the laser machine, and I've got some physical-ish electronics designs here as well. I didn't bother modeling the cables because I just don't need that. So yeah, we've got all the components here. With glorious and terrible Z fighting, which isn't actually present in the final STL files that go to print, but you know, stuff. Looks like I forgot to model the X-axis belt, but it is very much conveying a message of, hey, there's probably supposed to be a belt here. So yeah, let's look at some of the things within this. You'll notice that when I click, it doesn't actually do anything. That's because OpenSCAD is text-based. It is a sort of code-based CAD software. So you can see that you write out your declarative files like so. It's based on constructive solid geometry. So you know the basics are you have your shapes, your polygons or polyhedra, and then you do math on them in order to obtain more complex geometries, such as this cable gland thing here, or the sort of X carriage stuff there. And the other neat thing is that it allows all these parts to be very modular. So for instance, in the main assembly here, I've got I just reference some modules. For the X-axis, I can just define one module and use it multiple times. You've got the front bit, you've got the back bit with all the electronics, and then you've got the bits that are linking the frame together. And one of the reasons for that is that someone came up with a library of parts for OpenSCAD called NopSCADlib, which contains geometries for these extrusions, rods, stepper motors. They've even modeled the Arduino Uno board below that. Red board there. They've modeled the screws, nuts, bolts, zip ties, belts. There's basically definitions for all kinds of stuff that are that's useful to making a sort of machine. I think for their use case it was a RepRap style 3D printer. This is a laser machine. So the stuff I've I've contributed to the library bits and bobs there. Some of these are custom. I have had to model the laser module myself. I might contribute that as well, but not yet. Some of them you can actually quite easily reuse the same routines but define them differently. I think for like fans and things you can actually give them different dimensions and things, and it'll still draw you a fan. It'll do that parametrically, although like obviously if you're not using one of the predefined constants or predefined instances of a fan, then your fan might look a bit different, but it doesn't really matter that much in the grand scheme of things. So yeah, let's look at actually the fairly early thing that I've designed here, which is actually the y-axis. So yeah, the y-axis is a 3060 extrusion, couple of smooth rods on it. These holders are inspired by the ones from the Prusa i3. Similarly, the mounting system with the zip ties. There's the limit switches mounted there, and the little carriage assembly there for mounting the gantry on top of. And this bit has some serrations, I guess, or grooves, in order to accommodate the belt that goes through there, and just a bit of plastic in order to hit the limit switches, which I could have actually modeled into the carriage, but maybe that's for the next revision of this. Certainly, it has a facility that if you're running slightly more advanced stepper motor drivers, like the trinamic ones, you could possibly omit this and just rely on the feedback from the motors themselves and what the drivers give you. But I'm not doing that, so I've opted to just use normal limit switches there. Yeah. So the reason why I've started with sort of this design, like one of the more popular laser machines, laser designs out there is the Alex Maker, and that does look like a fairly good design. The problem is I couldn't actually use that same design here because I gave myself the stupid constraint of reusing parts from an existing 3D printer. So I had to build it around having 6 smooth rods of a certain length and stepper motors and things like that, like linear bearings. As I progressed into that project and as I stripped down the old 3D printer for parts more, it became clear that it just didn't want to do that. It basically just wanted me to kill it. So I couldn't, like, for instance, I had to buy new linear bearings, because although the ones in the old 3D printer were perfectly serviceable, well, first there wasn't actually enough of them for the full design that I implemented. But even then, I couldn't actually get them out because they were, like, I don't know, ultrasonically welded or molded into the plastic, the plastic bits that held onto the Delta towers which is where these were from, and that's also kind of giving giving a constraint of I have all these rods are equal length, so I can't do stuff like the LX Maker, which is taller than it is wide. My machine is fairly square. Rectangular. Yeah, that's the y-axis assembly. And yeah, this bit is kind of fun. So these are again press fit into the plastic bit, and actually I should open that file. So X carriage assembly there. That's the X carriage. But you can see, well, you can see a couple of different designs here. So the X carriage is kind of came later after I learned how to use more of the commands within OpenSCAD. So it's got these nice triangular bits. The Y carriage, which is what I was about to show you before I misclicked the file like some kind of a vegetable. Yeah, the Y carriage base assembly, which yeah is this thing. This is actually like a flexure in a way, because when you end up printing this hole will be slightly smaller, or slightly the wrong shape to what the linear bearings actually are, and that's because you're gonna print this like that on kind of upside down, which this actually comes out really well, despite the fact that it is upside down. Probably the slicer doing some kind of magic, but yeah, these bits, they end up actually expanding a little when you push the bearings in, and that actually gives them like very good grip on the bearings. So yeah, it's a nice little flexure thing, that just kind of holds them together, and that works even in PLA. In fact, like, I want to eventually reprint all these parts in PETG, but like right now it's running fine with just PLA. So let's close that. Like, on the other hand, this one is actually just two halves stuck together with screws, and the bearings themselves are embedded, or they're just press fit into those halves. I actually had to file down some of the material inside, in order to make them a snug fit, but it is also a very strong fit. Let me just show you how that works. So if I remove the back assembly, or if I remove the back STL, you can see how the bearings are encased in the plastic parts, and then we've got all the mounting screws for both the laser module, which is held up mostly by the front bit, but also by some of the screws from the back. In fact, I think this one screw is the special long one, which holds both the carriage together, the two halves of the X carriage together, and it also holds onto the laser module. So that actually provides a really good, stable, rigid connection between the two of them. And then if I go back and show you the laser module assembly, ignore that. if I show you the back, you can see the little grooves that I used to trap the two ends of the belt, and this is again inspired by the x-axis of the Prusa. Yeah. And then this gubbin I'll probably redesign before reprinting in PETG. This one just holds the wires coming out of a laser, and I've tried to figure out a solution to keeping them slightly more rigid than the sort of flexible silicone, incredibly flexible silicone insulation that they come with, because I don't want them to get cut by the laser, or mess up the workpiece. So yeah, that's the X assembly. Let's go to the electronics bit in a second. But yeah, no, the sort of basic y-axis stuff, like this'll kind of need to get redesigned, because I'm not very happy about using these pieces to adjust the belt tension. In fact, I'll actually show you that with the y-idler assembly. So the y-idler assembly, what I've done here is I've just made a sort of pill-shaped hole here, and what I ideally wanted to happen was when I tightened the screw, it would stop it from moving in what is here, the y-axis, but still allow this this idler to spin freely on the screw shaft. Unfortunately, I hadn't accounted for the flexibility of these wings here, and so when I over tighten the screw, it just kind of crushes onto this idler and makes it not spin very well. So I might try to figure out some solutions, like making a slightly thicker bit here, so that the when I tighten the screw, it kind of makes bearings. The idlers that I'm using have a bearing embedded in them, or I might try to redesign this for a completely different solution. I used to have one where the whole idler moved instead of just this, so I might be able to do that and use some sort of like star washer or something to kind of dig into the plastic a little and stabilize it. That's one of the things I could do. Yeah, let's go to the electronics bit. That's probably the most advanced bit of this whole thing. So electronics assembly. So you can see here that this is a box, and inside this box I have a whole bunch of stuff. And there's a lot of Z-fighting going on. Why is there a lot of Z-fighting going on? Well, that's because when doing this, I've hit a very annoying limitation of OpenSCAD. So if I go to the electronics assembly, yeah, I've actually had to put like I've actually had to change what gets displayed, like what gets added to the geometry when I'm in preview mode. So what I have here, right, is this very is this the base or is this the sides? That's Yeah, it's the sides and top bit. So when I save this now, at least one of them should... Yeah, so I have this nice little honeycomb pattern, or something approaching a honeycomb pattern, in the side for sort of passive cooling, or maybe I'll put a fan in there. I don't know yet. I don't think any of this stuff will get hot enough to warrant it. But maybe it will once I put more, like once I actually put the top on and stuff all the wires inside. Maybe that's going to be necessary. But the main thing is I was going for something slightly more artistic than just square cutouts, which is nice, but it also means that when I have all of them active at the same time, stuff just doesn't work. Apparently. Have I broken it? Show the console. Yeah. Well, once I enabled all of them, it just gave up, saying that there's too many elements. Which, yeah, fair enough. Might just be because of how I implemented the hexagons, which I admit is probably quite janky, but it's like it's a big limitation of this piece of software. And if I was doing this again, I probably wouldn't be using OpenSCAD. I might be tempted by FreeCAD, for which similar libraries also exist, or I might just do it in Fusion. The problem with doing it in Fusion is that I don't think I'll be able to like sell kits of this if I designed the thing in Fusion and still be able to claim the personal use license. I will have to pay for Fusion, which I don't want to do because I don't actually use Fusion that much, so it would just kind of be throwing money away. Which is why I'm interested in doing this in sort of free-ish software, or at least software that's a lot less expensive in the long run than using Fusion. So yeah, in this file, you can see that I've had to write a whole bunch of code just to make everything, I wouldn't say look nice, because it looks horrible and bears very little relation to what's actually happening. Okay, so let's take off the top half of the box. Let's just show this. Like, this red bit is supposed to be the Arduino CNC shield. And it kind of looks like it's got the 4 stepper drivers. The sort of general idea here is that I didn't actually want to model the CNC shield accurately. I just wanted to model it for the height when I included like the stepper drivers with their heat sinks and everything, screw terminals here. So like the whole point is you model kind of what you know that is going to be important. So like even below that, I've got the Arduino Uno model, which is actually done, like this is actually from the NopScadLib library, which is also kind of, it kind of looks like an Arduino Uno, but it's missing all the internal components because they're not really that important. What's important is sort of, where the connectors are, and here you can see that I've purposefully blinded the power, like the barrel jack power connector on the Arduino, but not the USB connector, and that's going to become important later. But when you do this sort of mechanical design here, what you care about is where your connectors are, sort of user interface input. So here's the reset button, which is definitely not going to be accessible, but that's okay. I can just break out a separate panel mount type push button for that. And then the sort of physical connectivity stuff, like the pins here and there, the standard Arduino pin header and the ICSP pins, and a general shape and vertical dimensions of the board. So that's kind of what I did here with these. Like the positioning of these stepper motors is only very approximate. Same with this, but I want to have something vaguely reminiscent of a CNC shield so that I kind of get reminded of where the important bits are. Sort of same with this thing. I just got kind of lazy and had the perf board thing here, and this is supposed to represent the laser driver board that came with the laser module, which I may or may not be making my own of at some point. But for now I'm using the supplied one. The reason I might want to write my own, software development stuff here. The reason why I might want to do my own is because in the previous video that I've uploaded to my channel, at least previous at the time of the recording, I've shown an issue where when the Arduino's in reset, or actually I've discovered when the Arduino's not powered and the 12-volt power is given to the rest of the circuitry through this barrel jack, which is a panel mount barrel jack, and the wires are routed into there. Like when only the 12-volt power is supplied, the laser is on. It's continually on without the Arduino inhibiting it. So it's not really a fail-safe design, and what I might want to do is figure out what exactly is going wrong there, and I want to design a driver board or something to sit in between this Arduino and the driver board to make sure that the laser can only be turned on by sort of a deliberate high signal from the CNC shield Arduino type thing. Because I don't want to accidentally burn the house down. That would be terrible. So I could, I've put a provision here for a toggle switch. I might move it. It's as it is. It's not very. So it wouldn't be in a very accessible place in the whole machine. I might have to move it to the top here. I might add another sort of slightly angled panel for this stuff. In fact, that would be quite cool. Could put a little display there for the sort of system status or something, if at all. Yeah, that's the electronics bit, and yeah, that's about it for the SCAD design. The other stuff that I have here is running Gerbil in laser mode requires some changes. So, and for the longest time I didn't realize this. The PWM signal for controlling the intensity of the laser comes out of the Z-axis limit pins, because not out of, and and this is where it gets kind of stupid, not out of the spindle enable pin, because what they've done is the spindle enable pin is a normal GPIO pin without PWM, whereas the Z-axis limit switch pins, the people who wrote Gerbil chose that needs to be a pin that also has PWM. I'm not super familiar with the different pins and what they do on the Atmega. Very 8 whatever Arduino microcontroller. I'm just kind of using it as a part here. But yeah, maybe there's an interrupt thing there that they want to be able to use interrupts for the limit switches, which might be a good design actually. But yeah, I had to include a config file which changes the homing. So yeah, so here the homing cycle had to be redefined to not touch the z-axis. Otherwise, it just kind of got stuck there trying to home a z-axis that doesn't exist. And also, if you know, if the laser output is connected to the z-axis input pins, and the z-axis stuff uses a internal pull-up, that just kind of means the laser would be on all the time, which is kind of stupid. So yeah, kind of the specifics of using Gerbil on laser machines, I guess. Some config stuff that I dumped out of the Arduino. This is not up to date yet, which is why it's not committed to the repository. I've actually had some issues with the auto-generated instructions. Oh yeah, the OpenSCAD lib actually lets you do auto-generated instructions and generate a whole bunch of images and things of your like auto-generated assembly instructions, which generates a whole bunch of pictures of the thing. I think applies a little bit of blurring with image magic to make it look not like utter garbage. But yeah, I've had some issues with this when using custom parts, like custom defined parts that also are supposed to hook into the system. That gives you the bill of materials. So I'll need to figure out what's wrong with that and see what exactly I need to do to generate the assembly instructions. Because I do actually want to have, you know, a reasonably good automatic assembly instructions, or at least automatic documentation. I might try and do some videos where I disassemble the whole thing and reassemble it again. Yeah. Maybe when I reprint all the parts in PETG and show you a sort of slightly more finalized version of this. This is still very much a work in progress for me. It's a learning platform, among other things, of like mechanical design and things like that, trying to figure out how exactly stuff like 3D printers and things are designed. As much as it is a cool laser project. So yeah. That's about it for this tour of the design side of the laser machine, and hopefully you will come see other videos that I do in this format on this machine and in general about stuff I make.